Welcome to the session number 2 from the playlist of Gravitation. So this session is in continuation of the session number 1, and the topic for the today's session is the gravitational field intensity. So based on this topic, I have written here 5 bullet points which will describe this topic in brief. So the first point here is the space surrounding a body in which another body experiences the gravitational force of attraction is called the gravitational field. That is, for example, let us consider that this is our planet Earth, and the dotted lines which I am making here is the region of the, or you can say this is the space around the Earth in which another body experiences the gravitational force of attraction. So the space surrounding a body, so this is the body, this is the body which is the Earth, and the space surrounding it, which I have denoted here with the help of dotted lines, is the gravitational field of this Earth. And when any other body, say there is a body there is a body here of say mass m. So whenever another body will come in the gravitational field region of this Earth, then this body will experience a gravitational force of attraction. So the space surrounding a body in which another body experiences the gravitational force of attraction is called the gravitational field. And the gravitational field intensity is basically the value of the gravitational force of attraction divided by the mass of the body which is residing in the gravitational field of the another body. So with reference to this Earth, the gravitational field intensity can be written as Gm. M is the capital M is the mass of the Earth, small m is the mass of another body which is residing in the gravitational field region of this Earth, and R is the distance of this object or the body from the center of the Earth. R is basically equal to R plus H, where R is the radius of this Earth. This is the radius of the Earth. So, and this, the height of this object from the surface of the Earth is equal to H. So, small r is equal to R plus H, where R is the radius of the Earth and small h is the height of this body or object from the surface of the Earth. So, the gravitational field intensity will be equal to Gm divided by R square, because here m and m will get cancelled out. And so this is equal to Gm divided by R plus H, because R is equal to small r is equal to R plus H, where capital R is the radius of the Earth and H is the height of the body of mass m from the surface of the Earth. Now we also know that the value of Gm is equal to gr square, because G is equal to Gm upon R square, where G is the acceleration due to gravity on the surface of the Earth. Here R is the radius of the Earth, M is the capital M is the mass of the Earth, so Gm will be equal to gr square. So I have substituted the value of Gm as gr square. So the intensity, this gravitational field intensity can also be written as gr square divided by R plus H whole square. So from this equation, that is I is equal to Gm upon R square, this is equal to Gm divided by R plus H whole square, which is equal to gr square divided by R plus H whole square. We can also say that the gravitational field intensity on the surface of the Earth, this will be equal to Gm by R square, because on the surface of the Earth the value of H is equal to 0. Now the gravitational field intensity at the height H above this Earth's surface, as we have already discussed, this is equal to Gm divided by R plus H whole square, or this is equal to G R square divided by R plus H whole square, or this is equal to Gm upon small r whole square, where r is equal to r plus h. Now, the third important point is that the gravitational field intensity at a distance r from the center of the earth, that is inside the earth, the gravitational field intensity at a point which is at a distance r from the center is equal to g multiplied by the mass of the earth, that is g capital M into r. R is what? This is the distance of that point from the center of the earth, divided by r cube, where capital R is the radius of the earth. So the value of the gravitational field intensity beneath the earth at a point from the center of the earth is equal to G multiplied by capital M into small r divided by r cube. So this is an important formula, and we all have to remember these important formulas. So this one is also a very important formula. Then this one, that is the gravitational field intensity beneath the earth at a point which is at a distance r from the center of the earth is equal to G capital M multiplied by small r divided by r cube, where r is the distance of that point from the center of the earth. So these are few important formulas which we all have to remember. And the next important point is that the gravitational field intensity follows the superposition principle. That is, the gravitational field intensity at any point in space is equal to the vector sum of the gravitational field intensity due to the individual bodies which are surrounding that particular point in space. And the last important point is, for a shell, shell, the gravitational field intensity inside the shell at all points is 0, and it is equal to Gm divided by r square outside the shell. Here r is the point which is outside the shell. So here r is the distance of the point which is lying outside the shell, and this r is also equal to r plus h. That is, r is equal to r plus h, where r is the radius of the shell. So for the in the case of a shell, the this gravitational field intensity is 0 inside the shell at all the points, and outside the shell this is equal to Gm divided by r square, where r is equal to r plus h, where capital R is the radius of the shell, and h is what? It is the height of the point above the surface of the shell. So thank you very much for joining this session. In the next session I will be taking up the topic of the gravitational potential, and in that session we will be discussing about the relationship between the gravitational potential and the gravitational field intensity also. So till then, have a nice day. Bye.